I'm Anil Kumar, and in this video we are going to understand characteristics of cosine function. You should know that cosine and sine are very similar functions, so let me just make a sine wave and then we'll analyze this. Okay, so I'm just making a sine wave here, so that's how we make a sine wave. Okay, now when we say we are working on cosine function, it really means that we have to start from a maximum, right? So that should be the starting point. So I'm writing this as my vertex on or the maximum value on y-axis, right? And we'll have this x-axis going along like this. So that becomes a cosine wave, right? That is how you can actually sketch a cosine wave. It is basically a sine wave. Let's say if I start from here, it is a sine wave, right? If I move it pi by 2 to the right, it becomes, I should say, if I move the sine wave kind of earlier, right, so to the left, it becomes cosine wave, right? So that is how we have to look into, right? Let me get to this point once again. If I had a sine wave here, it would have gone like this. Sine wave shifted left by pi by 2 gives me cosine wave, right? So what we have here is this is 0 and then this is pi by 2. That is pi, right? And it repeats after 2 pi, correct? So this is pi, this is 3 pi by 2. On the other side, this is minus pi by 2, minus pi, and this is 3 pi by 2, and minus 2 pi. So that is how it just continues and goes on and on. Now, what are the characteristics of cosine function? Like sine function, you'll notice that the maximum is plus 1, minimum is minus 1. And there is no restriction on domain of the function. So if cos x is our function, in that case, domain is x belongs to real numbers. There is no restriction. Range is that y belongs to real numbers. However, y is between plus and minus 1. So it is greater than equal to minus 1 but less than equals to plus 1. And then we have zeros, right? These are the zeros. Zeros, as you can see, are at odd multiples of pi by 2, right? So we can say zeros for the cosine function. Let me write cos x here and x here. Zeros for the cosine functions are odd multiples of pi by 2. Odd means 2n plus 1, right? That is odd number, multiple of pi by 2, where n belongs to integers. Is that okay? So these are the zeros for us. Now we have separate videos in which we have also developed relation between increasing and decreasing intervals, right? So you should look into those to find what are the increasing and what are the decreasing intervals, which should incorporate here. So increasing and decreasing intervals, right? So that is what you can see from here, that the function actually increases, let us say, from pi to 2 pi, right? So it increases from pi to 2 pi and periodicity is 2 pi. So add them by 2 pi each time to get your answer. Is that okay? So that is the increasing interval. And the decreasing interval is from 0 to pi, right? So 0 to pi, and then you add that 2 pi each time. So you get your increasing and decreasing interval. Another important characteristic here is that cos of x is an even function, right? Even function. When we say even function, we really mean that cos of minus x is indeed equals to cos of x, right? That is what we mean by even function. You also know that for a cosine function, let me show here, cos rule, right? So you remember the cos rule. It says C-A-S-T. Cos is positive in quadrants 1 and 4, but negative in 2 and 3, right? So you'll see it is even, right? So it has same values, positive, positive, for cos of theta and for cos of minus theta. That is how cos is an even function, right? So cos, like sine, is a smooth curve. Sine, or the other side, is an odd function. Try to remember that also, right? And it starts with a maximum. Sine starts with 0, correct? So the axis of symmetry here is y equals to 0, as in the sine function. You can write that also. Axis of the function is at y equals to 0, right? So all these things will help you in understanding or transforming and solving problems with cosine functions, correct? So I hope that helps. Now again, look into this video of increasing and decreasing intervals separately, since that will take some more time, and I'm keeping my videos short. And I hope this helps. So cos function is a continuous function like sine with domain of all real numbers, range between plus and minus 1, and zeros at odd multiples of pi by 2, increasing interval between pi to 2 pi, decreasing interval between 0 to pi, plus of course the period, which is 2 pi. So, and we also have period or periodicity of 2 pi's. That means every point repeats after 2 pi. Do you see? Every point repeats after 2 pi. Now for tan, periodicity is pi. For sine and cosine, it is 2 pi. I hope all these things come together and help you in solving problems related to trigonometry. Thank you and all the best.